So, have you ever wondered what a secret is actually worth? I don't mean in some spy movie. I mean in a real, concrete, dollars and cents kind of way. We usually think of information as this abstract thing, right? But what if I told you we can calculate its exact value? Let's figure out how to put a price tag on knowledge. All right, here's what we're going to do. We're going to start with $1 million question, then build a simple framework for dealing with uncertainty. We'll see what happens when a new clue pops up, and then we'll put our whole theory to the test with a classic puzzle. And finally, we'll get to the main event, calculating the exact value of a secret. By the end of this, you're going to have a new kind of superpower for making decisions. So let's kick things off with a scenario. I want you to imagine you own a piece of land, and you're facing a massive, high-stakes decision. There could be a gigantic oil deposit right under your feet. We're talking a life-changing fortune. But here's the catch. Drilling is crazy expensive. So the question is simple, but the stakes couldn't be higher. Do you take the gamble? Do you drill? And just look at these numbers. They're pretty stark. If you drill and hit the jackpot, you're up $1 million. Awesome. But if you drill and come up dry, you've just lost $400,000. Ouch. Now, if you decide not to drill, you still have some costs, so you're looking at a small but guaranteed loss of 50 grand. It's the absolute definition of high risk, high reward. Okay, to make a smart choice here, we can't just go with our gut. We need a system. So the very first step is to get organized, to lay out exactly what we know, and maybe even more importantly, what we don't know. We're going to start with this idea called a state of nature. And don't worry, it's just a fancy way of saying a possible reality. It could be it's sunny outside, or in our problem, there's a ton of oil down there versus the ground is totally dry. These are the basic truths of the world that we're trying to figure out. Now, here's where it gets really interesting. How do we actually perceive these states? Well, that's where an information partition comes in. It basically represents the limits of what you know. Think of it like you're wearing a pair of blurry glasses. Some of those different realities might look exactly the same to you, so you mentally lump them together in the same group. That group is one part of your partition. This table really breaks it down. If you're the most informed person in the world, you have the finest partition. You can tell states 1, 2, and 3 apart, no problem. Each one is in its own little box. But if you're the least informed, you have the coarsest partition. 1, 2, and 3 all just look like one big blur to you. Your level of knowledge is what decides how fine or coarse your partition is. Okay, so we've organized our own ignorance. We've mapped it out, but what happens when we get a new piece of information? A clue, a signal, a message? This is where everything can change. We actually have a logical, four-step process for updating our beliefs. First, we start with our prior belief. That's our best guess before we learn anything new. Then, bam, we receive a message. Step 3 is to think about its likelihood. How probable was it that we'd get that specific message, assuming the world was in a certain state? And finally, we combine all that to create our new, updated posterior belief. Now, I know that might sound a little bit abstract, so let's put this framework to the test. Before we go back and solve our $1 million oil problem, let's use our new toolkit on one of the most famous and most confusing brain teasers of all time. Right, the Monty Hall problem. So you pick door 1, the host, who knows where the car is, opens door 2 and shows you a goat. Now, our prior belief was simple, a 1 in 3 chance for each door. But now, focus on that likelihood column. This is the secret sauce. If the car was really behind your door 1, the host could have opened either door 2 or door 3. So the likelihood he opened door 2 is 1/2. And this is the key. If the car was behind door 3, the host had no choice. He couldn't open your door, and he couldn't open the prize door. He had to open door 2. The likelihood is 1. That tiny difference changes everything. When you run the numbers, your new posterior belief that the car is behind door 3 skyrockets to 2/3. You should absolutely always switch. See how incredible that is? This systematic approach just sliced right through all the confusion. So let's take that same clear-headed power and bring it back to our much, much bigger problem. All right, it is time for the main event. We are not just going to figure out the right call on drilling. We are going to calculate the precise monetary value of getting a little bit more information before we act. Okay, first, let's start with what we already know, our prior beliefs. Let's say, based on historical data for the area, there's a 24% chance of oil. If we run the numbers on the expected payoff from drilling, we actually get a negative number, a loss of $64,000. Well, that's worse than the guaranteed $50,000 loss from not drilling. So right now, based on this info alone, the smart move is to walk away. Don't drill. But wait, we have an option. We can pay for a geological survey. It's not perfect, but it's gonna give us a clue. This table, the likelihood matrix, just shows us how reliable the survey is. So for example, if the ground is actually wet with oil, there's a 60% chance the survey comes back saying, looks wet. And if it's actually dry, there's an 80% chance it says, looks dry. Makes sense, right? Now we do that magic we learned earlier. We combine our priors with these new likelihoods, and we get our updated posterior beliefs. And whoa, look at this. The change is huge. If that survey says, looks wet, our belief that there's oil jumps from 24% to almost 49%. But if it says looks dry, our belief plummets down to just under 14%. This changes the entire game. Our decision is no longer fixed. It now depends on the message we get. If the survey comes back saying looks wet, we recalculate our expected payoff with that new higher probability. And boom, it's a massive positive number. We absolutely drill. But if it says looks dry, the expected payoff is still negative, so we don't. That piece of information has given us incredible flexibility. The information let us make a much better, more tailored decision. But this brings us to the ultimate question. What was that geological survey actually worth? There's your answer, $97,798.40. That's it. That's the value of the secret. It's the expected improvement in our decision, averaged out over every possible message we might have gotten. This number is the absolute maximum price you should have been willing to pay for that survey, not a penny more. Now, this is so much more than just a cool math trick for finding oil. What we just walked through, is a fundamental tool for thinking. It's a genuine superpower you can use to make better decisions in any situation that's filled with uncertainty. So if there's one thing you take away from all this, let it be this. The value of new information is simply the difference in the expected outcome of your best choice with that new info compared to the expected outcome of your best choice without it. It's literally the value of being able to change your mind. And that leaves us with one final thought. Think about the next big decision you've got coming up. Maybe it's a career move, a financial investment, anything. Before you jump in, ask yourself, what's the value of finding out just one more piece of information? Because now, you actually have the tools to figure it out.